A supersonic transport or a supersonic airliner is a civilian supersonic aircraft designed to transport passengers at speeds greater than the speed of sound. To date, the only SSTs to see regular service have been Concorde and the Tupolev Tu-144. The last passenger flight of the Tu-144 was in June 1978 and it was last flown in 1999 by NASA. Concorde's last commercial flight was in October 2003, with a November 26, 2003 ferry flight being its last airborne operation. Following the permanent cessation of flying by Concorde, there are no remaining SSTs in commercial service. Several companies have each proposed a supersonic business jet, which may bring supersonic transport back again. Supersonic airliners have been the objects of numerous recent and ongoing design studies. Drawbacks and design challenges are excessive noise generation, high development costs, expensive construction materials, high fuel consumption, extremely high emissions, and an increased cost per seat over subsonic airliners. Despite these challenges, Concorde was claimed to operate profitably, although that was due to write-off of all development and construction costs plus the willingness of passengers to pay high fares. In 2016, NASA announced it had signed a contract for the design of a modern low-noise SST prototype. The designing team is led by Lockheed Martin Aeronautics. Throughout the 1950s, an SST looked possible from a technical standpoint, but it was not clear if it could be made economically viable. Lift is generated using different means at supersonic speeds, and these methods are considerably less efficient than subsonic methods, with approximately one-half the lift-to-drag ratio. This implies that for any given required amount of lift, the aircraft will have to supply about twice the thrust, leading to considerably greater fuel use. This effect is pronounced at speeds close to the speed of sound, as the aircraft is using twice the thrust to travel at about the same speed. The relative effect is reduced as the aircraft accelerates to higher speeds. Offsetting this increase in fuel use was the potential to greatly increase sortie rates of the aircraft, at least on medium and long-range flights where the aircraft spends a considerable amount of time in cruise. SST designs flying at least 3 times as fast as existing subsonic transports were possible, and would thus be able to replace as many as 3 planes in service, and thereby lower costs in terms of manpower and maintenance. Serious work on SST designs started in the mid-1950s, when the first generation of supersonic fighter aircraft were entering service. In Britain and France, government-subsidized SST programs quickly settled on the delta wing in most studies, including the Sud Aviation Super Caravelle and Bristol Type 223. Although Armstrong Whitworth proposed a more radical design, the Mach 1.2M wing, Avro Canada proposed several designs to TWA that included Mach 1.6 double OG wing and Mach 1.2 delta wing with separate tail and 4 under-wing engine configurations. Avro's team moved to the UK where its design formed the basis of Hawker Siddeley's designs. By the early 1960s, the designs had progressed to the point where the go-ahead for production was given. But costs were so high that the Bristol Aeroplane Company and Sud Aviation eventually merged their efforts in 1962 to produce Concorde. In the early 1960s, various executives of U.S. aerospace companies were telling the U.S. public and Congress that there were no technical reasons an SST could not be produced. In April 1960, Bert C. Manesmith, a vice president with Lockheed, stated to various magazines that an SST constructed of steel weighing 250,000 pounds could be developed for $160 million and in production lots of 200 or more sold for around $9 million. But it was the Anglo-French development of the Concorde that set off panic in the U.S. industry, where it was thought that Concorde would soon replace all other long-range designs, especially after Pan Am took out purchase options on the Concorde. Congress was soon funding an SST design effort, selecting the existing Lockheed L-2000 and Boeing 2707 designs to produce an even more advanced, larger, faster and longer-range design. The Boeing 2707 design was eventually selected for continued work, with design goals of ferrying around 300 passengers and having a cruising speed near to Mach 3. The Soviet Union set out to produce its own design, the Tu-144, which the Western press nicknamed the Concordsky. The SST was seen as particularly offensive due to its sonic boom and the potential for its engine exhaust to damage the ozone layer. Both problems impacted the thinking of lawmakers, and eventually Congress dropped funding for the U.S. SST program in March 1971. And all overland commercial supersonic flight was banned over the U.S. Presidential advisor Russell Train warned that a fleet of 500 SSTs flying at 65,000 feet for a period of years could raise stratosphere